Namaskar, my name is Manish Kumar and I welcome all of you to my channel. By the time you will be watching this video, we will be in next year. So Happy New Year to all of you, and I hope everyone's life gets better and better next year. So now let's jump to the topic, and in today's video we are going to talk about airflow architecture. So this video, whatever time it takes to complete, you should do in one go. So better, if you don't have enough time to complete this video right now, you can leave it and come later whenever you have enough time to go and watch complete video in one go, right? So now let's jump to the laptop screen and discuss everything in detail. Okay, so I am at laptop screen and we are going to talk about airflow architecture. So now first thing, we will be discussing about potential interview question, and here you can expect 40 to 50% of the interview question will revolve around this. It cannot be exactly the same, but you can understand the depth of this video that almost your half of the question will revolve around airflow architecture. And in this video, if you complete this video, mostly in today's video you want to get everything of it. So what I would suggest, to consume this video in more better manner, you should do it now, and then once we finish the entire airflow series, then again come back to this video and watch that time. Then you will have more clarity. Like in today's video you will know that what all things are there, how things are working, but once you complete the complete airflow series, you will understand from in depth, okay, why this was working, and when we were doing some of the things in later chapters or later lectures, at that time that will be explained in more further detail. So that is why I am asking you again, revisit this video after completing the series once. Okay, so now what all things are there, like, so in last class we wrote our first diag, right? And in that diag multiple things happened, but for us it was not on the focus. But in today's video we actually have to understand, when we were saving the file in diag folder, how that was working, right? So that is where I'll take you to the first thing, that is Docker container, which is running in our laptop. If your Docker container is not running, then you will have to do Docker compose up, or your in case Docker desktop itself is not running, then you will have to start the Docker desktop. Okay, so if you see this green icon here, that says it's running, so you should be seeing the same. Okay, what all things are there internally, which is basically mentioned over here. Worker is there, DAG processor is there, API server, scheduler, triggerer, Postgres, Redis, Flower. For Flower you can skip for now, but rest everything you can consider. Okay, now in today's video exactly we are going to see each machines and what is the use of each machines, how they are interacting with each other. That is what we are going to see. And to start this, first we will start with the scheduler. Okay, as you see there is a scheduler machine which is running, or when I say machine means basically a container which is running, right? So what is scheduler? So scheduler is called a heart of airflow, which manages our scheduling and triggering of the job, right? So here scheduler is the one who is doing the heavy lifting about when to run this task, how to run this task, what to run, what all DAG has to be run, right? All these questions has to be answered by scheduler. So the major portion which is being done by scheduler. Okay, so that is why this is called the heart of the airflow. Okay, so I have just written the same thing. It is the heart of airflow which handles triggering and scheduling of the workflow, right? Till now we are good. This is what scheduler do. Now I wrote another line which says also it submit task to executor to run. Now what does that mean, right? So there is a different set of process which is running, and that is called executor, right? In one of the video I think I was talking about executor. So there are multiple type of executor which is there, but here I will stress on one point, that scheduler and executor run in the same machine. So scheduler is the actual machine inside which executor runs. So executor is a configurational file which runs inside a scheduler, right? There are multiple type of executor which are there, like local executor. We might have seen celery executor, and this is what we are running as executor in Docker compose file, that we will see in like we are going to see further about this celery. Okay, and then there is another one is Kubernetes executor. So these all are running inside the scheduler, and here executor is the one who submit the task. So now there is a difference between scheduler and executor. Scheduler is telling about what to run and when to run, right? So here if I zoom on this scheduler task, scheduler talks about what to run. Basically it talks about which DAG has to be run and when it has to run, right? So these are the two things that scheduler is answering, but executor is answering how it has to run, like what command has to be run, right? These kind of questions, and where it has to run, right? So these are the two questions that is basically answered by a scheduler executor, and two questions are answered by the scheduler. And executor is running inside a scheduler, executor is a configuration file which runs inside a scheduler. So these things, I hope it is getting clear now what a scheduler do. One more thing, here if I have a local executor, right? Understand this very clearly. If I have a local executor, scheduler, right, plus executor plus worker, all three processes run inside one machine. Okay, but if I am using celery or Kubernetes, then scheduler plus executor will run in one machine, but worker will run in different machine. I have not talked about worker. So worker is basically the one who does actual task. Okay, we will further see about worker. There are a lot of things to discuss inside the worker itself, but for now you can consider worker is the one who does the actual job, who run the actual command, which is basically in last class we were saying echo commands, right? So echo command is being run by worker, not by scheduler, not by executor. These are the people who are maintaining the scheduling part, and how, when, where these questions are being answered, but exactly where it is running, that is inside worker. For now this is enough to talk about worker, but we are discussing about executor. So in case of local executor, we will have everything in one machine, but when it comes to celery or Kubernetes, we will have two different machines. And here we will basically, if you are running Kubernetes, this will be inside a pod. Okay, now let's understand how a scheduler knows, right? How a scheduler knows that which task has to, or which DAG. Basically when I'm saying task or DAG, at least for this video, you can I am interchangeably using this. So whenever I say task or DAG, same thing. Okay, just for this video. So yeah, how scheduler exactly know what task has to run and when it has to run, right? So here basically scheduler uses a queue. Okay, scheduler uses queue, and there are two kind of queue we have available in scheduler. Okay, everything is interrelated, that's why we have to understand each and everything. So q1 is basically a database backed. Okay, it's not a actual queue, it's a basically there will be no Kafka, Redis or any kind of queue system. It's a database backed. So basically whatever data is being stored in the database, and for us database is Postgres here. That also I'll show you in a moment, but for now it's a Postgres. I think 1S or double S, I don't know. Okay, so this is a database backed. This is not a physical any kind of queue system, but what it does, it stores the information that okay, which one has to be scheduled, and that is where q1 comes into the picture. Basically this is one of the code which is running inside a scheduler, which continuously pulls the information from metadata, and that is where it comes to know okay, this task or this DAG has to be run, so I'll put this DAG or task in a queue, right? So this is called q1. Now once q1 is completed, this information is being sent to the Redis queue. For us at least it's a Redis queue, right? And any physical queue. So Redis queue, it is being sent. How it is being sent? Executor is sending this information. Executor sends exactly the command which has to run, and it basically executor push the message to the Redis queue that okay, this task has to run, right? There are two queue, one scheduler. Inside the scheduler it is running, database basically continuously pulling the information from the database, putting it in a queue, and once the q1 is there, then it will go to the q2. Q2 will basically push the message to Redis queue, and Redis queue will pull the message and send it to worker. Okay, so this is how scheduler has a two queue system. So here I have written the same information so that you can make a better notes. It's a logical queue, not a physical like Redis or Kafka. This is for q1, and for q2 I have written a statement here. Executor publish the message to the Redis, that is what I told you, and what to run, and worker takes the task from the queue and run it. Okay, so this is how scheduler are using two queue and executing the job, understanding what to run, when to run, where to run, how to run. All these things are getting answered inside the scheduler. This is why this is called the heart of Airflow. So now we are good with scheduler, at least we understand what a scheduler is. Now we will move to the next part. Next part will be from here, it's a DAG processor. So we are going to talk about now DAG processor. So in last video we were saving the DAG inside a DAG folder, and that DAG was being shown on the Airflow UI. How that was being done is basically this DAG processor. So DAG processor was doing all the heavy lifting that we were thinking how this is running, right? So basically DAG processor, right, parse the DAG folder, okay, parse the DAG folder and store the DAG info into the database or metadata database, I would say, right? Basically for us it's a Postgres. So now you understand why the DAG was getting populated on the Airflow UI and how that was being populated. So this was the DAG processor in action. There are few more things to discuss here, but before going there we will understand DAG processor in little more detail. So that is why I have this. Okay, so this is, so now understand here DAG processor has two process running inside. That's why I have this two arrow moving downwards. First is DAG file process manager. So this is a class name which is written inside a DAG processor. I'm not going into the code, but you can verify the same method in the code base. Okay, and the second one is DAG file processor process. So these are the two classes which are responsible for parsing our DAGs. Okay, see here what it does. So first we wrote the code and we put it in the DAG folder. Now process manager will go. Process manager will basically what it will do, check for new files. How it will check for new files? Based on the time, right? Once it gets the any file or any new file or the updated file, how it will basically exclude already processed file is based on the hash based comparison or time based comparison. Okay, so these are the two things that it does by checking for new files. And then already if it is checking basically if the file has been already processed or do I need to process again. Then it will move to the next part, and next part is queue only newly discovered file to path. So if already file has been passed in the last time, so we don't need to pass it again, and that is where this queue to the new folder, new path basically. Okay, there are 5 total DAGs, but 2 DAGs one has a newly created and one has updated. So those kind of information has been put it in the path. Now this will, after that it will call the DAG file processor for each file. For each file it will call. So from here flow will go here. Okay, and it will go to the so now actual work which is being done, initially DAG file process manager just checking if the file is present or not, so which is newly created, which is updated, and then it will basically call the process file processor class, and there will be a file processing will be being done. Now when the file is being processed, see here what I have written, listen carefully this line: load modules from file like import. So whatever the import statement that we write, that has to be parsed. Okay, so from here one point comes is like in the DAG you'll see there are many people who is writing, let's say def abc, and inside this now you will see import statement. Most of the time, like as a developer, we write all the import statement on the top of the file, but this time you will see import statement being written inside the method, and this is being intentionally written because we don't want to get it parsed again and again, which is not basically required during the parsing time. We just need a DAG overall flow. So that is where this import statement, if it is being written, this will not get parsed, and we will not, like our DAG parsing will not take much time. So why this is a concern, that even if DAG parsing is taking time, so we have a 30-second configuration set to parse the DAG, right? So each 30 seconds our DAG will be parsed, and where this configuration is there, this configuration is there in airflow.cfg. you can check it there, or if you want to when we start the docker compose file, inside this docker compose file also we can give some configuration to change from 30 seconds to some different, or in airflow.config also we can change from 30 seconds to let's say 120, 100. So this is where there is one performance bottleneck, is that if you cannot parse entire DAG in 30 seconds, then basically that DAG will not be shown on Airflow UI. So you will have a concern there. Like if you have a thousands of DAG and then you are not parsing it within a time, then you will have a problem, right? So this is one of the configuration, and this is how optimization can be done, either by increasing time or by putting this import statement inside the method, not on the top of the file. Okay, so this is one of the things that is what I have written here: load modules from file like import, and then return the DAG bag, or DAG bag is called DAG object. So DAG file processor process will process the file, do all the imports, and whatever the object is getting created, it will send it back to the DAG process manager. So from here our flow will come somewhere here, right? And at last I'll just remove this part, this is not required now. Okay, so after that flow will come here, and it will basically collect the result, right, from this one DAG file processor process, collect the result and send statistics like how much time it took to parse the DAG. So this is how our DAG processor works internally with the help of two classes, which basically parses our DAG based on hash comparison and time based comparison. So now this DAG is getting parsed, right, and this is also getting stored in the metadata database, right? Just now we talked about. So now what I am going to see, now you can say, okay, you are talking everything theoretically, right? But I'm not seeing anything in action, right? So that is where I'm going to show you the things in action. So how will I know that our DAG is parsed correctly and where it is getting stored in the metadata database, right? So first, now we will go to the metadata database, right? So this is where I am introducing the database as well, right? Metadata database will store all the information about your DAG in different set of tables like DAG, serialized DAG, task instance, logs, everything will be stored inside the metadata database, and for us it's a Postgres, right? Now we have the machines running, right? You can see here Postgres is running. So now I want to see the table, right? If I have written some DAG and if I'm not able to see it in the database, then how will I be making sure that, okay, this is how this is working, right? So now I'll take you to the database and I'll show you exactly how things has to be, like how things are stored there. Okay, so the table which are utilized for at least this part, the one that we are discussing, is serialized DAG. So serialized DAG is the table where our all the DAG information is getting stored. Okay, so now we will go to the this one, Postgres database. How will I go inside this database, right? So that is where two things has to be come into the picture. First I am going to explain the first way and then I'll explain you the better way. Okay, so now I'll open a terminal, or you can open a command prompt if you have a Windows machine, right? And now we know one command which is basically docker ps, right? This will show all the processes which is running in our machine. And here I can see where is this is Redis, this is Postgres, right? This is the Postgres machines and this is the container ID. I'll copy this container ID and now you tell me the command. Which command do we use to go inside the container? It's a docker execute -it, it for interactive terminal, and then container ID, then bin/bash. See, we are inside the Docker container. We are not inside the Postgres DB. We are inside the Docker container, right? If I do ls here, I can see all the Linux file which is there, right? Now I have to go inside our database. So how will I go? PSQL, right? -u for username, Airflow, and U is capital one, -d, and then password is also Airflow. So this is how I am inside Airflow database. See here Airflow. If I do \dt, so this will show me all the list of tables that are getting stored in the database, which every time we are talking about metadata database. This is what the database is. This is how database looks like. Okay, and everything is running in our container. So here if you see serialized DAG table is there. That is where our all the information of the DAG which we are writing it will be stored. Okay, so I'll just do Q for quit and I'll describe \d and then describe this table name. So it has 5-6 columns like DAG ID, data compressed, created at, last updated, DAG hash, and DAG version ID. So all these informations are stored. Now I want to see the data. Select star from serialized DAG, right? This is how we write the SQL query. And now you can see here the data is there, right? But you might be saying this is not the good way to see the data, right? Everything we are interacting on terminal, that's good, but most of the time it is not as pleasing as we see, and it's not very human readable to get all the information in at one glance, right? That is where I'll introduce you to the tool which generally being utilized in the industry, at least I have used, is dweaver. Dweaver is a tool. You can use PyCharm also. You can use IntelliJ also. In IntelliJ or in PyCharm we have a database connectivity, but that should be a premium this one IntelliJ account or PyCharm premium account, not in the free community edition. So I already have downloaded dweaver. So I'll go to the dweaver tool. You also have to download it, dweaver tool, or if you don't want to, then you can just see in the terminal itself. But if you do that, it will be good. See, in one of the channel, for the previous channel which is in Hindi, I was talking about the same thing. So that is where this is basically running. But for now, I'll remove this connection and show you everything from scratch. Okay. So here the first thing I have to do another thing to connect in the dweaver. So again I'll do exit here, and then I'll do exit again, right? I'll do a little bit small here because I have to show something. Okay, docker ps. If I do docker ps, this is the process which is running, right? If you see here on my machine, it is saying 000 and 5432 is being forwarded to 5432 inside the container. But in your machine, it will not be showing up. In your machine, just it will be like 5432/TCP. Something like this will be there, because there is one more thing that I have done. Basically, I have mapped my system, like my local PC or laptop. So basically I have a laptop. This laptop port number 5432 is getting mapped with 5432 inside the Docker container. This what you will not have done, because in the Docker compose file I did not had written this. I did not think about that, but once I was creating the lecture, then I came across, okay, well, I'll have to show the data as well, right? So that is where you'll go to your VS Code. So here what I'll do, I'll go to this path. Sometime you guys say that git pull is not working, so go to the correct directory, then only git pull will work. I'll do git pull. It says already up to date, but for you it will not say up. For you it will not say already up to date. For you you will get this 2-line extra added when you run the git pull. Or else if you have downloaded it, then just put this port number 5432 in the services of Postgres inside this Docker compose file. If you don't do this, then your machine will never know that 5432 where this 5432 has to be port. Okay, so I consider that this you have ran, and also you will have to do docker compose down and then docker compose up, because if we are making change in anything about docker compose file, to take the effect in action, you will have to down the system and then again up the system, right? So that is what you will have to do. Now we are good, and we will go to this what it is called is dweaver, right? So we'll go to the dweaver, and now I'll click on plus. So basically I'm adding the connection. Once you are done, for you also docker ps will show something like this. If this is not being shown, then you will not be able to run this next step which I am showing on the dweaver tool. Okay, so I'll go to the Postgres SQL is there, right? Then because we have a Postgres DB, right? Here localhost is localhost because 000 is localhost. Database name is not Postgres. Now our database name is Airflow, that I showed you in the when I was running docker execute command. At that time also I showed you, right? Username is also Airflow, and then password is also Airflow. Now I'll test the connection. If everything works, it is connected in 37 milliseconds. Okay, so now everything is working. I'll just do right click SQL editor, open SQL script, and I can just do a drag here, drop down, and I can see Airflow. Okay, schema public tables. So you can see here all the tables are here, and now you can explore any like job, log, right? Where is our task instance? Where is serialized DAG? This is the serialized DAG. So now I can write a script like select star from serialized DAG, and now I'm getting this suggestion. I'll run this, and this is how we can see the data, and this is the data that is being shown on the Airflow UI. The next question will come how Airflow UI will come to know. That also I'll explain, but for now understand this database and then we will go to the UI wala part. Okay. Here everything is in place, like just now I showed you the describe table and all the column name was there, like DAG ID. So see here DAG ID. Now I can see there are two DAG ID with the same name, right? But if you go to the right side, you will see the different hash code, because I made a mistake in the last lecture that I did create the everything lecture, but I did not screen capture it, and I told you in the last lecture. That is why I have two DAGs, because when I was explaining you for the second time, it was created another DAG with the same name, and that is where by mistake you know about now DAG versioning. So this is what a DAG versioning is. There is a different DAG version ID, so I can run the same DAG with a different version which has been introduced in Airflow 3.0. But now, for now, we are not going to talk about DAG versioning. For now, our concern is how our data is getting stored. So I can copy this data and I'll just put it in Notepad or anywhere, right? This is the JSON data. This actually our entire DAG, past DAG information is here in this way. If I copy the other one, I will, because there was just one task in this one, save API output, and this save API output, you know where is it is coming from? Lecture number 2, where I had given you the extra one Docker compose file and everything to run, because we are going to utilize that API endpoint to run our Airflow jobs or scripts in further classes. So here, if you see, this is the second DAG. I took my first DAG, basically my first DAG name is my first DAG, and that is called DAG ID. So if you see here, every information is there. We just have to find it out. See, this task 2 is there, and then also copy file will be there. Copy file is there, right? So everything is here. We just have to figure it out. Now we understand how database is storing this data through the help of DAG processor, right? Just now we were talking about DAG processor and how data is getting stored in the database. Till we are good, right? Now I'll go to the container again, and now I'll see what else is to be discussed here. So the next thing we are going to discuss is API server. Why API server and how API server is showing the Airflow UI. So now, by now you will be very much familiar with Airflow UI, right? So if I go to localhost 8080, this is what Airflow UI is, right? So how this every information is being fetched is from the database, but database how internally, like also, so this information, like okay, first before going there, we'll go to this page and we'll understand a little bit more about the API server, right? Okay, so API server is basically our UI. For now you can consider this everything, like API server is basically managing our entire UI portion. UI is written with fast API plus React. Okay, so React for front end and fast API for back end. So this is basically a back end, this is front end. So the front part that you see is being done by React and the back end is being done by fast API. Before 3.0, I think there was it was a Flask, but now it has been a fast API. Okay, so there are few changes in Airflow 3.0. This is one of the change. I'm not sure if this is being done in Airflow 3.0 or it was before also, but initially it was a Flask and now this is a fast API. Okay, so UI, the complete UI which we are seeing right now is being handled by React and the backend is being handled by fast API, and everything this, okay, this is also called initially we used to say web server. So if I say web server or UI server, API server, sorry, web server or API server, don't get confused, both of the things are same only. Okay, so UI is being done here and backend is being done here. Now how will I know that because this is called API server. So everything will be working with the API side, and that is why I always stress you to learn about API either from my channel, but my channel is in Hindi, so you will have to follow some other channel where you can learn about API, at least a basics of API, because we are going to use a lot about this API. Okay, so how this API server is pulling the data from database and showing it on UI, right? That also we have to understand, right? And we have to see those things in action as well, right? So now I'll take you to the API server. Okay. So what I'll do, I'll go to the Airflow REST API documentation. Okay. You can go to Airflow REST API documentation. Open this one because every API endpoint is written over here. We just have to find out which one we have to use it. Okay. Although everything is being utilized by React plus Fast API, and also we have this information written over here, so you can get any information that you would need. We were utilizing this DAG and get DAG for showing the DAG on a different UI by our user to our users in one of the like when I was working at Geo, this was the information that we were utilizing, right? And then offset and all those things were implemented there, that I'm not going into detail. But for now I'm going into the DAG. Okay, get DAG will give you the all the list, or you can use this get DAG and pass the DAG ID and you will get the information of just particular DAG. For now I'm just planning to get the list of all DAGs that is showing up here, so I'll use this get DAG. Okay, I'll copy this link, right? This is basically the API endpoint. And for us, right, we know that we are running localhost 8080 and this is written airflow.apache.org. This is not our server, right? Our server is http colon localhost 8080. If I hit this, wow, we got the DAG. Entire DAG information is here. So this is how API server is running. Now you understand how API server is running. It pulls the data from database. If I go to the database in the DAG table, this is what information will be stored there, right? See, everything we are getting now. So this is how API server is running to run our backend. And for the front end, you already know that UI is there. So API server is basically reading and writing the data. Reading data, most of the time reading data and then showing this entire UI. That is what we call the API server. It also update, right? It also update the data based on what we have clicked here on the UI. See, one more thing, because I am seeing on this page, remember this number 128. Okay, just remember this number 128 as a pull slots. I'm going to talk about in some later point, but remember this point. Okay, so if I go to here and if I go here my first DAG and if I trigger it, so when I click on trigger, basically, of course not now, when I just click here on trigger, it will insert one entry into the database. So from UI we are basically putting the data into the database. If I click trigger, it will basically run or fail, whatever things are happening, all the details will be written into the database. There are a lot of things happening inside, but if I click these things, if I am updating anything, let's say I'm pausing or unpausing the DAG, right? So our DAG is running. If I do pause or unpause, those things are also getting stored into the database. So those kind of things are being done by API server. Okay, so hope you understood about the API server. It reads the data, it writes the data, it updates the data. It depends, right? What all things has to be done either from UI, from backend or anywhere. But this API server is one of the core component of Airflow, which is basically talking to the metadata database. Okay, but be sure that API server does not schedule the job. Job has to be scheduled by scheduler. It just has to store the information. Okay, just don't mix and match the concepts here from here and there. Okay, now time has come to talk about the next internal architecture. Next, where is our next machine, right? So we did not talk about worker till now, and actual task is being done by worker. So whatever the command, echo command that we were writing is being done by worker. So how this worker is running, we will see in action now. Okay. So by now we know worker, right? Worker runs the actual task, right? And how worker does that? Scheduler generates a scheduler has two queue. One queue will be Redis. Redis push the data like scheduler or executor push the data into Redis queue. From Redis queue, worker will pull the data, right? And it will basically start the uh, worker process to run our task. So how things are working internally, I'll show you one architecture and then I'll explain further from there. So this is what our worker execution flow, but remember that because we are using Celery as an executor, so we have a worker which is a Celery worker. Okay. Now this worker execution flow, listen carefully. See what we did. Scheduler had a queue which pushed the data into Redis, but of course we know that executor pushed the data. Now worker process will pull the data from here and it will generate a worker child process. Okay, and worker child process for each task. Now everything is being done for one task now. So from here this will create one local task processor. Okay, and that local task processor will actually create a task runner where our task is running. That task runner, of course I have given this arrow, but this arrow is not working this way. Task runner, whatever the status is there, it will return to local task process, it will return to child process manager, and this will return to worker process, and worker process finally will write the status to result backend, and then result backend scheduler will pull the information and it will write the data back to the database which is our Postgres, right? So this is how entire worker flow is working. I am going to explain once again about this flow because this has to be remembered clearly, like how things are running internally for the worker, right? So scheduler schedules it, right, or push the data into the queue. After pushing the data into the queue, scheduler start pinging the result backend database, right? Now scheduler is not communicating further to the worker process, it directly starts communicating to the result backend, and result backend will give you the status. Okay, this is running, this is running, this is running. This is how this scheduler will come to know that when task has been completed, so that next task has to be scheduled. So scheduler will push the data into the queue, and then worker process will start another worker child process for each task, and then from there local task will be generated, and then task runner will run. Task runner will give the information to this will give the information to this will give the information to this, and this will store the data into result backend. I just give the arrow like this last time just to showcase. Okay, this is how after task runner everything is going into the result backend, and from there scheduler is pulling the data. Once a scheduler gets the information, it is pushing data into the Postgres, and Postgres is basically showing on the UI. So this is how we come to know, okay, our task is running, right? So this is how worker process is running. Hope you understand how worker process runs, right? Now I'm going to show you one mental map, basically mind mapping about airflow, all the components talking to each other. Okay, this is a little complex, looks like a little complex workflow, right? And actually it is, but I'm going to explain you with all the details, so it will look pretty easy. Okay, see, each component, I have the major component, whatever we have talked about, web server or API server. This is web server or API server. So that's why I told you, if I use the term interchangeably, don't get confused. Okay, so API server is communicating with worker. How it is communicating, that I'll show you in a moment. Worker, listen carefully this line, worker cannot directly communicate to the API server. worker direct cannot write the data to the database, and that is where it take the help of web server. Okay. So this is worker here, this is diag files, database, right? Scheduler, broker, Redis, basically you can consider Redis, and result backend. So these are all details we have talked till now. Now see here, all the communication is two way, but I have shown the arrow in one direction. Web server having three green lines, and each has a different set of color line is going. So from web server, three green lines are going there. One is going to the worker. It is getting the task execution logs. We have implemented task SDK and task execution flow. That is from where this task executions logs are getting generated and being shown on the API server. Of course, this is getting stored in the files as well as tables, but that I am not going into details. For now, you can consider the communication between web server and worker is to share the logs. Web server and DAG files basically share the DAG structure. Web server and database share the status of tasks. That is what we see on the UI, that okay, this is in running state, this is in schedule state, this is in error state, right? So those kind of information we are seeing from here, right? Now talk about worker. So worker is communicating with result backend. Just now we saw, because the status of task is being written by worker process into the result backend, and worker is basically communicating with each other. So worker is the whole flow, and inside this there is a different component, result backend, where this information is being written. Same goes for DAG files. DAG files gives the structure to the worker. Every worker should know what is the structure of the DAG. Worker is also communicating with the database. Yeah, here worker directly cannot communicate to the database, but there is a API server involved in between that will help you to get the information. But for now, it is important that worker is communicating with database to get the connections, variables, configs, and XCOMs. Okay, XCOM is cross communication. Variable and connection we will learn in the upcoming lectures. Now scheduler. Scheduler is talking to the database to write the status, like it is in schedule state, it is in whichever state. Then also it stores the diagram and task details, everything that is basically stored by DAG. Then the another yellow line is going to here result backend. It is basically getting the information from the worker, everything what is happening, and then storing it into the database. Then here it scheduler puts the command to be executed in the Redis queue. So this is how, at least for now, this entire flow is working, right? One more thing which I have not talked about, and then after that I will show you one simple diagram which you can explain in the interview. For now, you can consider this is how the mess is running there inside Airflow to talk with each other. Okay. One more process which is I have not talked about, and you can see it here, is triggerer. Apart from this, we have talked about everything. Okay. So now we'll talk about triggerer. So understand the situation here, okay? And most of the time we are in such kind of situations when we are running the job, especially the big data jobs in the Airflow cluster, right? So we are running the job. Let's say this is a EMR job or any kind of Spark job, which takes 1 hour or 2 hour or 10 hour, any times it takes, right? Till the time EMR job is running, right? Our scheduler is involved, right? And a scheduler is involved, and it has some fixed slots, right? So let's say scheduler can run 50 jobs or can handle 50 jobs at a time. So it can handle 50 jobs at a time, and for this task already, like for EMR job, scheduler is not doing anything, but this is involved with the worker, that okay, is it done, is it done, is it done, like this is what it is being done, right? Scheduler is involved. One slot is basically blocked by the job for, let's say, 2 hour, right? I'm just removing 1 hour for now. Let's say for 2 hour EMR job is running, and for 2 hour we are doing nothing, but our particular slots are blocked. So now this is a challenge here. Why this is a challenge? Because just now I told you to remember one number, that it was 128. So for now in this machine at a time, scheduler can run 128 tasks at a time, not more than that. And that is where this is a challenge. We cannot scale our system. To scale the system, we would need either a different machines, or we should optimize our machines properly. That is where trigger comes into the picture, and it says, since your job is running and you are doing nothing, you are just pulling the message and your entire slots is blocked. So why can't I take all the simple tasks? These are the simple tasks, just pull and push the message. Okay, is it done, is it done, is it done or not, right? This is what trigger has to do. So trigger comes into the picture and says, okay, you free up this task, you can take another task and give that task to me, and I will handle it from here onwards. Okay, listen carefully. Schedule, it says to a scheduler, you free up those slots, you use for another task to run and give it to me, I will handle this issue. Okay, and when I was saying scaling, one of the issue I remember that I'll tell you in a moment, right? Scaling issue was there in DAG processor as well, that I'll talk about, but for now you can consider here, we will focus here on triggerer. So I have this simple architecture of triggerer, how things are working internally. So worker is there, right? Worker is doing the task, everything is being done by worker. It's just that scheduler is talking to the worker what is being done, and those slots were booked. So what worker says, okay, since you know that your task is taking more than 20 seconds, 50 seconds, then what I'll do, I'll defer this task and put this status as deferred in the database. Okay. So if I put the status as deferred to the database, what it will happen, worker will defer the task, because it till the time it was communicating to the scheduler, but now it will defer the task and DB status will be deferred. So worker will basically, or DB task will basically generate one trigger, and those trigger is a async loop, which is basically just pulling the information. So a small trigger machine can handle hundreds or even thousands of tasks, because it's just a asynchronous loop which is basically pulling the information, right? And once the task is completed, what I'll do, triggerer will tell scheduler that okay, now this task is completed. So basically now communication is happening between worker and triggerer, not between worker and scheduler. This is how we are able to free up this space. Now once this is completed, what I'll say, okay, I'll write this information to the scheduler, okay, now this is done, right? Or rather, I would not say it to a scheduler, I'll just change the state from deferred to none into the database. Once I set the status from deferred to none, scheduler will by default pull the data from the database. So I would say this way, then I think it will make more sense, that scheduler will again, so this will push the data as none to the DB, and now since this is none, a scheduler already knows that this task has to be completed. So scheduler will pull the message and it will pull the state, push the status as scheduled, and again the next task will be in running state. So this is how entire trigger will run. I'm explaining you once again because I think last time I make you a little confused here. So worker will run, it will call the defer. Okay, I'll clear these things. So worker will call defer, it will put the status as deferred, it will call the trigger event will put the data into the database, again from database we will pull the scheduler will queue the next task, and then again worker will be working, and if worker has to do the same task, like again worker has to wait for 2 hours, 3 hours, then again the same flow will be running. And this is how we are not blocking the scheduler, and everything will be running as smooth as possible, right? Okay, so now scaling issue was there, right? When I was talking about DAG processor, I did not talk about the scaling issue, right? So listen here, initially we had DAG processor, right? DAG processor plus scheduler in one machine. So both of those things were running in one machine, and everything has to be done in 30 seconds to process. So that is where people used to tweak this and change it to 2 minutes, like every 2 minutes I want to pass the DAG. So that was 120 seconds, but that was again the scaling issue due to the DAG processor getting stuck, right? So now we have a two different set of process. One is DAG processor and another is scheduler. These are two separate process. So now we can independently scale each of the machines without getting much worried about both of the machines, right? So this was one of the things that is done by removing like segregating the DAG processor from the scheduler. Okay, so this one I think I missed last time, so I talked just now. And now comes to the final architecture which we are going to talk in the interview, but to understand each of the things we had required all this information in detail. Now I am going to show you this architecture, and this is the one which is we are going to talk in the interview. Listen carefully, I'll explain these things again for 2 times and everything will fall in place. Okay, so now understand here how things are working. We write the DAG, right, and we store the DAG in the DAG folder. And this is a client server architecture. First of all, this is a client and server. So inside the server side, only 3 components are there now: scheduler, API server and database. So basically whichever the system which can directly communicate to the database will be on the server side, which directly cannot communicate to the server side will be on the client side. This is what being shown here. Okay, so we write the DAG, we store the DAG in the DAG folder. DAG processor parse it. Now we understand how DAG processor parse it. And there is in process API server, but you can forget about in process API server. You can directly say the DAG processor communicates, right, communicates to the API server. You can see here this dot is basically communicating to the API server. Once it communicates to the API server will write the data back to the database, right? This is our database, Postgres database. Now once we write the new DAG into the database, what scheduler will do? Scheduler will start pulling and scheduling it if the time, like of course the scheduler things that we talked about in the initial phase, where it first checks whether it has to be scheduled or not, time has come or not, right? And then only it will put it in a queue, right? And the scheduler has 2 queue. Those things will run internally. Now if a scheduler finds it that okay, this has to be executed, so executor will take in place and executor will come, right? Executor, and then executor will push this message to the Redis. Again I'll put it here, a Redis one, and then Redis will communicate to the, like from Redis worker will pull. But for now I'm just removing the Redis part for the simplicity, and scheduler will basically communicates to the worker, right? And worker, if worker takes a lot of time, then worker will initiate trigger, and trigger will write the status as a def word to the API server, right? And once API server is involved, like a def word, and then once the status is set as none, again API server, from API server DB will be changed, and once DB status is changed, scheduler will come into the picture. Scheduler will run the again the entire flow. So this is how all the components in one bigger picture working in order to serve the entire Airflow orchestration. Now you understand how Airflow works internally, right? So we have all the components which was required. I'll again explain the same thing one more time, because this is quite important things to talk here, right? So again I'm going to write the same, I'm going to discuss the same flow. DAG, we write store, go to the DAG processor stores the information to with the help of API server to the database. From database, a scheduler pulls the message and executor starts pushing the message to the queue, Redis queue, and from there worker starts. If worker taking a lot of time, it will go to triggerer, and triggerer will write the status as diff word in for the first time, right, to the database, and for the second time once this completes, it will write again status as none. From none to scheduler will pull and then schedule it, and then the next process will start running. So this is how our entire Airflow running. But now you understand each and every component in details as well. So if someone is asking you about the architecture of Airflow, you can talk in very detailed manner now, right? And this is now a client server architecture where only server can communicate to the database, and there are two servers, scheduler and API server. These are the two servers or two machines which can talk to the database. Rest everything cannot talk to the database. They can talk with the help of API server, not directly. And now we understand API server. Now we understand how API internally works. Everything is in place. Of course, we don't all these things, but to understand in more depth, the next, like whenever we will be learning about these things internally more and more, we will be in good shape to talk about everything with the concrete knowledge now. Okay, so for now I think we are done with this lecture. Already this lecture is for, I think, 1 hour long video. We will meet in the next video, and till then, bye bye.